So, day two, what we're going to be covering today is going into Ansible proper. By this point, with the labs you guys went through yesterday, you've seen the basics of how we can talk to our devices directly using our APIs. You've seen the basics of what we do with Cloud Vision when it comes to the REST APIs, and you can see how there's beginning to be a bit of boilerplate attached to these operations. So from there, what we get into now is taking Ansible and laying it on top to start abstracting some of this out. Then we're going to be going through some low-level details on what Ansible actually is, how it operates, what they term collections and modules, how to read their docs, because that is crucial to actually using it. And then we're going to be discussing the Arista-specific collections for Ansible. And at the end, we'll have 3 labs based around Ansible, walking you through some basic operations, direct device interaction via Ansible, and device interaction via Cloud Vision. So, Ansible, it is one in a galaxy of automation tools. Others you've heard out there, Puppet, Chef, Salt, Nornir, like we talked about yesterday. These are all tools that are made with the goal of, gee, I touch a lot of devices. I hate this. It's all the same. Can we make this simpler and automate it? Yes. So Ansible was one of the earlier ones. It came out originally in 2012. And when it first came out, it was targeted at the server space. Ansible didn't actually pick up support for network devices until about 4 years later in 2016. Because of this, there is some idiosyncrasies in how Ansible talks to network devices, but it's still very usable. Like we said, this is an automation tool. This can do a lot of things. Effectively, in most scenarios, you're going to be using it to drive to some end state. What this means is that basically you will have your devices, whether it's a rack of servers, a network, what have you, in some original state. You want to get it to a goal state, and you give it steps to walk it there. In the best scenarios, what you do is you write playbooks that are idempotent, meaning if you run multiple times, they will not cause additional unexpected side effects. They will just see that the system's already in the desired state and change nothing. Ansible does not force idempotency like tools like Puppet do, but just keep that in mind because for some things you do, that can impact how operations proceed. Like most Python interactions, very simple. You just go ahead and install it basically. If you are on a Mac, you have brew as well. You can just brew install Ansible, gets it in place. Under the hood, when we're using Ansible in a standard mode, what happens is we connect to our target devices over SSH. We actually ship Python code to those boxes and then run it locally and get the output back. That's the standard mode. This doesn't work for network devices in general because for a long time, most vendors would not expose a Bash or Python environment to you on those devices. Because of this, some tweaks have been made. This is where the idea of local execution comes into play. In local execution, when you flag this for Ansible, you tell it, hey, don't connect those devices and run the Python code there. Run it locally to do something, and that's how we'll connect to the devices. So what you'll see when talking network devices, we use local execution, and we'll target HTTP API or SSH, and we'll drive those interactions via local execution of code, not trying to get to the remote device and run it there. Things to keep in mind, especially if you are using mixed playbooks where you're touching, say, servers and network devices in the same playbook, there's some nuance in how you do your targeting and your connection rules to avoid different kinds of issues. 99% of the time, the code you'll be seeing as far as attack basis is going to be network devices only in playbook, and you're going to be using local connection or HTTP API flagging. Under the hood, when Ansible sees those, it changes the actual execution path. There's really 4 main categories we get into when you talk about how Ansible is operating. There's a concept of inventory and variables, which is data you're feeding in to do something. You have your plays in your playbook, which are concepts of how you take input data and use those to perform target operations. Roles and tasks end up being how we package and distribute code to be run by other users. It's similar to how you have a library in Python. The verbiage here matters because of how Ansible does their imports. And then ultimately there's modules. And these all tie together to give you this platform where you come in, you feed it a list of devices, you feed it a playbook, and it goes out and does the work for you on your targets. So, two different formats we can have an inventory file for Ansible in. The first one, the less common, is INI. It's less common, still have notes because it can show up. What you'll basically see is something like this. By default, your host or inventory file lives in etc Ansible hosts. People almost always override that. You can see it stored there though, especially if, for example, an IT or network team has a box that they just used to run Ansible. They may store it there then. Typically though, you're going to see some sort of inventory.yaml file in a given directory of your playbooks, and they'll have an Ansible config file there that tells it, hey, override the default, use this inventory file instead. Like you'll see on the right here in my example, there is this grouping concept with INI syntax. Basically, at your top level, you have the all group, which is all your devices. And then you'll say the group is composed of these child groups, in this case, leaf and spine. Within my spine group here, we then describe two hosts, DC1 spine 1 and DC1 spine 2. And we have details here about what the connection IP is to talk to them. You can pass other parameters as well, but most of the time, the one we're setting is just Ansible host. Same concept in leaf group here. We have more child groups that compose the leaf group. So that's rack 1 and rack 2. And then within those two groups, they each have two hosts. We can then also define overlapping groups where, for example, this group is composed of these hosts, which can also talk about these groups. So it's not a strict tree that you must enforce. You can have overlapping groups to allow for detailed and nuanced targeting, depending on what your playbook needs are. So we talked briefly about INI. Let's look at YAML. You guys have seen some YAML from yesterday. You're going to be seeing a lot more of it. When you're talking about using an Ansible inventory file in YAML, there's different forms you can write it in. I've got the nested definition on the left here and the top level group format on the right. These are functionally equivalent in terms of what they will allow you to do within a playbook, but as you can see, they're written differently. The main thing you want to take away from this here is that just because you get into a call sometime and see an inventory file from a customer, it looks different, it doesn't mean it's wrong. There's no hard and fast prescription of what the inventory file is to look like as long as the group targeting works. We'll go more into later in this presentation about how we debug group targeting, but just keep in mind you can have nesting like this. Any questions here on this YAML layout or what this is showing as far as the inventory?
Yeah, for children, can you mix groups and hosts? So if I realize that my tenant networks includes all of rack 1, but only one host out of rack 2, could I target rack 1 and the host from rack 2?
Yeah, so you wouldn't put it in the host key. You'd have under like DC10 networks 1 here, you would have a children key, and you would put that group, and then you'd put the host as well.
Okay.
You'll see an example of that in lab 3 today. When you get to that, the inventory file is written will have that syntax there. You'll see an example of that when you're looking at the EOS group. The EOS group has child groups of other groups that are previously defined.
Nathan, can we have two different children, like for the main parent file, like all? Can we have two different, like for two different DC locations, or it's just one file for one location?
You can absolutely split it up, but you're going to have to start looking at using things like imports. Typically, until you're getting to a point where it's very large, it's not great because then it becomes hard to reason about because you have to look through multiple files. But let's say you start splitting your inventory one file per DC, but you run your playbooks against all of them simultaneously. You now have to have 5 files open and merge those in your head mentally to figure out what's going on versus one where you can just look through and see where it is. So typically what's going to happen is people are going to scope the inventory file to be their entire fabric. Now I'm saying fabric here. In most scenarios, customers are scoping their fabric to be a DC. So they run plays against a single DC, or maybe a pair of DCs. And then they'll have different folders and playbooks, different fabrics. It's a common pattern. We see it with multiple different customers. Zoom is one of these. Again, a lot of flexibility, which is part of the issue in trying to troubleshoot some of these things. There's very few ways that things can be hard and fast wrong unless they just don't run. There's a lot of tweaks people can make to their configs.
Yeah,
I would encourage you to do time in the lab. Go ahead.
Yeah, I'm just trying to understand the file format. So will there be a nested file, something like that? Like a main file which will have all the DCs, then DCs will be divided in different YAML files or something like that?
So you're just asking like how to split your inventory up?
Yeah.
So I guess what would be the use case here? Are you just talking like a very large fabric?
Yeah.
So a couple ways you can do this. One, yes, you can build multiple inventory files and pass them all to Playbook. So let's say you have 4 YAML files for inventory. You can pass all of them at execution time and it will parse and merge them all together into one data structure. You can also put them into your config.
Okay, makes sense.
Nathan, sorry, quick question. So the difference between the left example and right hand side example is that we on the right hand side we don't specify default all group. Is that the only difference?
Yeah, on the right, I'm not specifying the all group. You'll also notice I'm basically in most scenarios, I'm not using children. There is one here for this leaf one, which I
think
I'll have to
the
correct
rest
there.
is just they're identical for the rest.
Yeah, I'm thinking I'll correct these later. There was another image here. I think it got moved.
Okay.
Sorry. Yeah, we're gonna have to look at that. Yeah, I'll come back to that because there is a difference. That's supposed to be there.
Also, Nathan, I think the 3 dashed lines on the top of it when starting up a YAML file, will that be also part of the syntax when we are referring to a YAML format?
Yeah, so like we talked about yesterday, technically you can remove those. It's
Okay.
not compliant, but it
Okay.
can be done. So you'll see examples of both. And also just because when we're doing slides, it's hard because of how long these get vertically.
Right,
We
right.
do try and trim some of the output just so things that aren't really relevant get
Makes sense.
emitted.
So basically, it exempts the compiler exempts that 3 dash lines on the top of it if it does not have. Is that right to say?
There's no compiler per se. A compiler will imply you have some sort of compiled format. What's happening here is you have a loader, really interpreter, that's just reading your text and creating a data structure from that.
Got it.
So you're just parsing it.
Okay, sure. Thank you.
And yeah, just comparing, when you're looking at YAML versus INI, again, some differences. YAML is the format you're going to see more often, just because it's typically a little easier to reason about deeply nested groups. INI can be trickier as you scale that out. So we were talking before about how you might want to debug group membership. Say if a playbook is not targeting what you think it would. One easy way to do that is you'll run this command here you see on the left, just Ansible inventory. You'll feed it your inventory file. In this case, we're using an INI, we're not using YAML. You'll tell it, hey, graph this. What will happen then is you'll get this tree graph like so. Ansible will tell you how it's interpreted group membership. So each of the ats here is a group. And then below that, you have membership. For nested groups, you'll see it shown like this. There's one special group here as well, you'll see, called ungrouped. When you have something, a host, under all, where it doesn't have a grouping, it gets placed into ungrouped. So that's another way too, you can look at debugging things. If they're complaining about a device that's not being targeted by, say, a leaf playbook, you can look and see if it's ungrouped. If it is, well, that's why. So let's talk some about variables. Ansible has a key concept of feeding in input data via variables, which are basically just Python data structures. Traditionally, they're stored on disk as YAML files, or they're fed in via upstream plays or tasks as Python data structures directly. What you'll see, we're looking at a variable file on disk, is that it's just YAML. And like you'll see here, we've got some sort of nested structure. Typically, when you're working with AVD, you're going to get a fabric file that has a bunch of fabric variables. Things like you'll see here, where we're listing underlay and overlay loopback, underlay, TTP, and overlay loopback address ranges that we'll do math on to figure out IP allocations. We can also include things like a dictionary of spine configs. We can do the same for end hosts, leaf switches, DCI interconnects, what have you. These are pretty flexible. Again, they're just Python data structures, so you can go nuts. The problem is if you make it very complex, you then have to reason about your complexity. So it usually helps if you keep the data structures relatively flat and just work on the fact that you have these dictionary structures here so you can add new keys at will. We'll also see in some labs today is that we will define variables in line to playbooks as well. So you'll see variables both being loaded from on-disk files and within the playbook. There's also the concept of these special variable locations. We're talking about Ansible. There are folders that will hold variables that are loaded implicitly at runtime based on the host and the group it's running against. So what you'll see, again, with labs today, is there is a bunch of folders called group vars. Within that, you'll have subfolders with the name of a group. When Ansible runs against a device and it sees that it belongs to a certain group, it will load all the vars it parsed for that group into the execution context for that device. Same thing for the host vars basis. All that's scoped to a host itself and not to a group. So it's even more specific. If you want a comparison to the CloudVision, you can think of these as being container level configlets and device level configlets in terms of the context scoping there. And of course, your default grouping just has everything. We'll also see people use is sometimes they won't use the defaults folder, they'll use the all group because every device belongs to all. Questions so far in the variable system and how that's laid out? Okay, sounds good. So, like we talked about, you'll have these on-disk layouts where you get into host vars and group vars. So like you'll see here, we have, in this example, a number of devices that will have their own variables to load. There's also group variables will load based on what group you're part of. If you're tagged to being part of DC1 Fabric, we load these and run these variables for you. If you're part of the servers, you get the server variables. We can also bring in the different variables we load from our roles. Roles are something we'll cover as well a little bit, but effectively, again, that's like a library in Python. It brings in additional functionality. You can also bring in additional variables. So, tasks. This is the key component of an Ansible playbook. There is a diagram I'll show you here in a second where we break this out, but effectively a task is the smallest unit we will operate on. Tasks are composited into a play. Plays live in a playbook. So in a given playbook, you can have multiple plays like this, where they can do different groups for targeting and different connection types. and then do sets of tasks. This matters because you can have plays look at different groups to build data out in one step, and then use that data they got from talking to first group devices to do something to a second group. And it's this targeting system that allows us to go through and step and sequence what's operating within the playbook. So when we talk about tasks, this is where we actually call out the actual actions that happen against the devices we are targeting within a play. Every task has a name. You don't have to name it. You can get an option. You can get a default one, but I like when you do this because when the actual playbook's executed, we will print out the task name and device it's targeted against, so you can follow along with execution. Very, very helpful for debugging. And then, like you'll see in this next page here with our playbook example, every task has a module we're going to run and the arguments to run with that module. So in practice, when we look at a task with this one here, you can see this task is named just O2 configure configurates on blah. And what's happening here, you might notice, is that we are doing Jinja substitution directly in the playbook. So based on what the host name is that we're running against, the name of the task will change when it's printed out. So this is an early example of how we start using Jinja to drive dynamic outputs within Ansible playbooks. You'll see as well that the actual module we're using for this task is the CloudVision configlet module. We'll get into what that does later, but effectively for this, we are passing this module a bunch of variables. Here they're called CVP facts, configurates, and filter. And then it is going to go and do something against our hosts with this module. In this case here, our play is against CVP. So all the hosts with the CVP group will have this done to them. And again, we are doing more Jinja expansion here. We are loading in a special Ansible variable called facts and giving it a dictionary subset from this. And we're also passing in a configurate list that we parsed earlier. So as you can see, this is getting to be a form of meta programming, where what we're doing is we are altering what's going to happen with the execution based on prior state from the same playbook. Very helpful. Questions so far on how the plays and tasks operate? Okay, we'll keep going then. So, roles. We spoke about these a little bit prior. Roles are one of the main ways we will package Ansible code for reuse by other people. Effectively, when you build a role, you package up handlers for how it interacts with devices, you'll package tasks, you'll package templates, and your tests to make sure your role works as expected. These all get packaged up and usually distributed by Ansible Galaxy, which is the equivalent of PyPy for Ansible. And then they are imported into playbooks and run as part of user operations. So you'll see a number of roles get used as you're using Ansible. The main ones you're going to see in customer environments are going to be, of course, AVD, but then also Arista.cvp. The Arista EOS roles exist, but they are used less because we don't control them, and they're just, plainly speaking, not as good. Modules are about how we actually interact with devices. So what you'll see, like if you click this here, and I'll again publish these slides later, what's going to happen when you look at these modules here is for network devices, there is this whole list of pieces of code you can pull in to speak to different vendors and different product lines. These get composited and used in playbooks to actually speak to these. As you can see, there is a ridiculously huge list of modules available for network devices, which is part of why Ansible is so popular. If you are a customer and you have a multi-vendor environment, that used to be pretty painful. You would have one set of APIs to talk to one system, another set to talk to your second vendor, so on and so forth. With modules like this and the ability to run plays considering devices in a playbook, you can write a single playbook, a single piece of execution that runs across your different vendors and stitches outputs together to actually achieve something useful. And this is a big deal for some customers. Let's say, for example, you've got Arista devices and you've got a Juniper firewall. Okay, that can be a little painful. We don't even speak the same kind of API syntax. What Ansible's allowing you to do is to abstract that and then take the outputs from one system and pass it to the other and create these higher level functions that end up being a lot more useful to you. We also, of course, have core modules that provide just basic functionality we use both on box and on remote boxes. The big ones you're going to see us use a lot are template, copy, and file. We use the other ones as well, but not as much. They're typically used more in a server context, and we're really focused on the network device context here. But you'll be using some of these in the labs today, and basically what these do is these modules expose new functions in Ansible that you use to do operations within a task. This shows you how we can start using that template module. What you'll see here is that we're calling it, just like anything else. We create a task where we give it a name, and then we call the template module, and we're passing it two variables. We're telling it, hey, your source is this, your output is this. What template will do then, and we'll show you some of this documentation as well, is it goes and it will load that Jinja to template file. It will take the variables you have in the current execution context, template them in, and output them. So, like you can see here, the current execution context for this play has this dictionary where we've got one key of keyword and the value is learning. So we load this Jinja 2 template, we take our variables, we say, okay, the value of keyword is learning, and we output this text file. This is the basics of what we're doing for most of our work in Ansible, just at scale. We take big data structures, we run them through templates, we output text, we put it into a switch. Again, the name of the game with this is just we're doing something simple, we're doing it fast and a lot, and that's what makes it very powerful and saves time. Copy module works similar. You'll see us use a bunch when you're moving files around for doing things like backups, testing operations. In this one here, all it's doing is under the hood, your copy module will be calling out to your local file system constructs, which will differ between Windows and Linux, and it's moving files around. We can also get more complex as well. You guys saw yesterday, we can go out and we can talk to different APIs with the request library. We can do the same with the URI module within Ansible. So in this example here, what we're doing is we are passing a templated call to a given endpoint like you would in requests. We're telling it, yeah, just use get, and then we get a response. So this call goes out, it happens under the hood with the implementation Ansible chooses, and the implementation can be swappable. We get a response, we store it in weather. And this until statement here will tell it to wait until it comes back as 200 OK for the HTTP response code. Once that is done and the fetch completes, we proceed to the next task. We actually dump out that output with this debug module. The debug module is another one you'll see often used a lot in Ansible. You'll see it used in your labs today. It's a way to dump the current state of your playbook execution at a given point in time. And here, obviously, once we do this, you'll see the output based on this call is this. Questions so far on how modules work?
Quick question. I had some issues before, didn't really have time to troubleshoot. Maybe when we are calling module from the task under the playbook, at which point does Ansible load up default variables from the module? Because I thought it would load them at the point where the role is called, or I'm sorry, it's actually the role where the role is called. But in the end, it looked like it loaded them up right away, like even before it started the gather facts. And because of that,
yeah,
is that the case?
So unless you register a variable your vars are going to be loaded at context creation. Context creation is used because it can be different things. Typically, it's going to be scoped to a play. So your play starts up, Ansible goes and says, okay, you have these inline vars, I have these host vars, these group vars, I have these role vars. Takes all those, composites that. That is your execution environment. Get facts then runs if you didn't turn it off. We'll get to that in a bit as well because that's caused problems sometimes. Get facts runs and it can load additional data in to your facts variable in your context. And then from there, execution takes place.
Thanks.
So just a few more examples here as well. Anything you can do on a system, basically, there is a module for Ansible because it was originally built to do server operations. So especially when you're doing kinds of testing like this, you'll see we have ways to manipulate the state and modes of files on a given system. If you're trying to do testing where you have to do very fast change and things like that, it can be helpful to do that with a set of tasks in Ansible and loops. Again, just a rehash. When we're talking about Ansible, typically what you'll do is you'll have a top level directory for what you're working on. Like in your labs today, each lab folder will be its own top level directory. Within those, you'll have your config file telling overrides to use. Ansible will look for and implicitly load your Ansible config file when it runs, so you don't have to pass command line flags to do things to override inventory all the time. Your inventory files, of course, based on what you've done in your Ansible configs, will get loaded. By convention, they're stored in the top level. They don't have to be. You can move them elsewhere and update your config to point to them. You'll have your playbooks, again, at top level, because you'll read them at context. And then your host vars and group vars will be there, and you'll tree out your groups below those to give you the outputs you want, and those get parsed at runtime. We talked before briefly about how Ansible has a system called Galaxy, which is functionally similar to PyPy for Python. This is what it looks like. You will see it occasionally. Effectively, when you build something for Ansible that you want to share with other people, what you do is you package up your set of playbooks, your roles, whatever you've built into this collection format, and you upload it to Ansible Galaxy. There are some rules that exist for Galaxy. They do require some basic level of testing and test coverage, things of that sort, to ensure no one's just pushing crap up, including the namespace. But if you look through Galaxy, you'll see a whole bunch of different designs available there to do various operations. Obviously, the AVD system lives there and can be installed with Ansible Galaxy. There's also the EOS and CUP collections, as well as we'll call them fan-made ones, like the Arista base config one you see here. So a lot can be done with those. We really just scratched the surface when we're using it for networking. But if you want to see some really interesting examples, I'd say look at some of these server collections for Ansible. So let's get into the actual use of this. When you're using Ansible, there's a couple CLI commands that you'll get familiar with. There's Ansible inventory, there's Ansible playbook, and there's just Ansible itself. When you're using just Ansible by itself, you're effectively running a one task play. So in this example here, what we have going on is we are running a task against all groups in inventory, and we're using the ping module. The ping module is a special Ansible module that does not operate like ICMP ping. What it is actually doing is making sure it can connect to the target host, running Python, getting a response back at Pong, and exiting. So that allows us to test a couple of things. One, does it have connectivity? Two, does the device have a valid version of Python? And three, does it make sense? That's basically their sanity check mechanism, which is what ping does. When you're using it with network devices, there is some subtle overrides that happen where we can check just the HTTP API, we can get into Python, or we could just ping it. And that's defined really by this network OS variable that we carry around in our inventory and config files.
What's the changed variable or value that it returns for?
What do you mean?
Well, in the Ansible all ping, it gives you both ping and pong. It also says
Yep.
changed is false. So obviously changed is important enough to show the output. What would be the scenario that you would see that? Does it try to change if it doesn't get a pong, does it try to make changes so that it can, or?
So change is a basic thing that tasks carry around with them. It's just showing it to you. It really, you guys they can strip it, but they don't. What change is showing you is if the output will have changed. So like if you're pushing a diff, it'll say change equals true and such. That's using summaries. In this case here, I could ping it, I can still ping it. It's not terribly helpful. What you're looking for in just ping is just a success. Change matters more when you start getting into things for tasks that will change the system. For example, how am I even get like shape from my
Okay, so
testing?
changed is something you're going to have in every task. And if you were doing something that would conceivably make a change if it wasn't configured already, then that value will change to reflect whether or not you actually had to do something with the task.
Right. So let's go. Like you'll see this here. This is an
Okay, I see it.
example. Yeah, this is an example of running against the entire fabric we have. And in this scenario, I am doing a number of plays. Tasks. There was a total of 6 tasks that run against each device in this play. And what you'll see here is that for each of them, a certain number of tasks end up with a change. So this is telling me, hey, 3 tasks changed something for this guy. They were all okay. For this guy, only 1 changed. That's because of some templating work I was doing. None of my tasks failed as unreachable. None of them failed because of issues executing. We didn't skip any of them, and we didn't have to go and rescue. Basically, this is used for output. Just use an operator to know what's happening. As your fabrics get larger and your plays get longer, you want to look at these summaries more. Just be aware of what's going on in the system. Obviously, as well, for every single task we have, you're going to see a per task output summary like this. So this task ran to run the API, they'll come back okay. This task ran to load banners. For some of these devices, I already had banners loaded, so it didn't do anything. The other ones, it had to change a banner, so its count has changed.
Correct me if I'm wrong, but I believe you can also override that behavior too. So on a per task basis, you can force it to return a certain status code back instead of whatever the default is. So
Yep,
like if you have a thing that says it's going to be a change, but it's not actually a change, you can say like just mark it as not, basically.
Exactly, because you can use these control codes to then figure out if you want to skip or run later tasks as well. When we're using the ping module, we just don't care because it just doesn't matter. Like if your ping module is changing your devices, you probably want to check, make sure it's actually make sure it's the ping module. Is that clear the question, JB?
Yeah, I'm good. Thanks.
Okay. So we talked earlier about looking for group membership. There's also scenarios where you want to look beyond just group membership and look at the variables available for a given context. Again, here we're using just the base Ansible command to run a one-shot task, and we're targeting leaf 1. So in this here, what we're doing is we're saying, hey, pull leaf 1 out of inventory, run the debug module against it, and these are your args for what to do with that module. So when you pass these args to the debug module, it says print out these vars. And this gives you a data structure, which is what we execute at runtime. And you get this very, very long output of every single variable that's available. You execute for that device context and what the value will be. You can also, if you don't want to use the debug module, just use the Ansible inventory commands and tell it what host you want to look at. And then they'll reach out, they'll look at your inventory, they'll figure out group composition and tell you the same thing. Both methods works this way. And again, like I said, it's a very, very long output you get for your debug output. This is what ends up looking like. You'll see here, obviously, we're including a whole bunch of things prefaced with Ansible. That is usually going to be a default value. We do dump this out as well. For some of these, we are going to include things like your config files and everything else. Once you start getting down into your groups and those other ones, you'll see things like group membership available. You'll see the variables you set, so on and so forth. There's like 3 more pages output here. It just becomes too hard to read it. We'll make it that large for a slide. Special variables. You may have already seen in the previous few slides, we're using this variable called inventory hosting, both in Jinja templating for the plays and in the outputs. These are used and set by Ansible under the hood as execution proceeds. So inventory hosting is always going to be the current host you're iterating over in a play. So if you use that in a task, it will tell you who it's running on. Group names is always a list of the groups the current host belongs to. Your host vars, of course, are the hosts you have in your inventory and their assigned variables. And Ansible facts is where you put any facts that were gathered for the current host. Alexi asked about fact gathering earlier. That is a mechanism that Ansible has that is on by default, where before you actually work on a device, it will reach out and gather some basic state. The goal of that was, and this is working on servers, is you want to be able to make these idempotent operations, like we talked about before. The idea being, if you have a user already created and the playbook says create a user, just skip it. Don't do it again. Don't do weird things like that. Similarly, if you have an RPM installed, don't reinstall it. That could change the state of the system. So we would use these facts with our tasks to skip operations. On EOS devices, gathering facts doesn't work great because of how Ansible wrote the Ansible EOS collection, which they own and operate. So typically in our plays, in our playbooks, you'll see it, we turn gather facts off and we just don't use it. We will use fact gathering against CloudVision to do things like collect the state of the system before we talk to it. So we'll use that to collect things like the list of containers, the list of configlets, and then we'll diff that against our desired state to figure out the delta that we want to push to a system. And things like that delta computation can be a little complex to do on your own, which is why Ansible is nice, because we can make that diff operation pretty seamless under the hood. And then just to reinforce, of course, because we have these 2 special host names, this is how we get the vars for the current device. This kind of pattern can be used all across the product. You can use this to dump debugs like this. You can use it to debug during a playbook execution. You can use it to dump outputs to a file if you need to, and parse them later for other executions. Any questions around how the inventory works or any of these variables? Okay. So let's talk about actually running a playbook. We're finally getting to the point where we're going to do something that is close to what we'd be doing in production. When we're running playbooks, we're using this Ansible playbook command. You'll see here as well, we have this -i flag for an inventory file. This is where if you didn't have an Ansible config specifying your inventory file to use, you would use this to avoid using the system default host file, which is almost never useful. And to your question earlier, Macucar, if you had split your inventory into multiple files, you would pass multiple I flags with those inventory files and we'd composite those. After all this, you go through and you give it the actual playbook you want to run. It reads that, parses it, and does operations. So if I have a playbook with a task block like this, you'll see that when you actually run your playbook, it goes out, decides, okay, to make this config change, I have to fully run a config, get that back. I need to then diff that to figure out if it's missing these trunk group tags. And then if they are, I will emit the config commands to add it, to drive to this desired state where this is in my config. And it's this system of diffing that's where the power of Ansible really becomes shown. It's not just like CloudVision, where effectively we wipe the config and apply it all and switch to it for us. Ansible tries to be smart, and when it looks at what a system has and what is desired, and it only does the diff. Basically, what we're trying to do with CloudVision with Delta config. The problem is sometimes Ansible is too smart for this. There's been a number of cases we had in the past where effectively something about our config system will confuse our Delta, emit the wrong diff and do the wrong configuration, things like that. So just be aware, this is not magically faultless. This can still mess up. And again, just another simple playbook example. Now we're actually getting into talking to devices. What this play here is doing is it reaches out to all your leaf hosts and it's going to run one task to actually speak to it, pull outputs, and then it's going to dump them to you. So a few more things you're going to be seeing here is that we are compositing with this with items argument into args, a list of commands to run. The US command module will take that, execute against devices, and store it in this var called EOS command output. And then the next task, we are dumping the contents of that var to CLI. So, Ansible templating, like we've been talking about, it's Jinja 2. You are going to see an incredible amount of Jinja 2 because it is everywhere in our code logic. We have a refresher here. This will help with the slides today if you need to for the labs, like you've seen yesterday. Effectively, what we do is we start slamming control structures into blocks of text. So we can start doing things like checking for features. If a feature is on the expanding tree, we emit the configs for it. If not, we can skip it. And so we can create these very, very flagged templates and emit a final config that matches what we want. What you'll see, especially in AVD, is that we create a lot of template files, usually one per feature, and then they are pulled into a main template file with the block syntax that Jinja 2 has to make the full thing. So rather than having like a 10,000 line template file that is impossible to read, we have a very simple top-level file that pulls in features in the order they're defined, more or less, and then each feature template has the actual logic for that feature. When we talk about this again, we have lists, we can do looping. Looping can be interesting. You are going to see a lot of logic around this. If you're not familiar or comfortable with Jinja, I would say do some small scale testing. There'll be some opportunities in the labs today to do this. And of course, any questions, we can show examples or walk through those. Sorry, I just got to think of something. Again, we just have more template examples here for Ansible about how we're actually been using Jinja. And we've got this very, very quick pipe in Ansible where we've got that core module. We can call it to Jinja, run it through, get a response, use it in the actual task. So let's take a larger example. In this scenario here, we have a vars file. And we're just calling this underlay DC1. What you'll see within AVD is that we will build files like this from a design module, or sorry, design role. But what we're doing here effectively is we have a top-level dictionary with 4 keys, and then those keys in turn have dictionaries within them. There is one key in those dictionaries just called interfaces currently, and then that dictionary has the actual interfaces, and then those have keys for the IP address we're using. So what we'll do when we're using something like this, within a play is we will say, hey, for this set of tasks here, we are going to take the vars from this file. You're going to parse this YAML into a data structure and store it in the underlay variable. So this is now a complex nested dictionary that we can use in later calls. And then what will happen here is once we have that registered, you can then reach into the data structure and pull things out. And you can also use it for templating. You may notice we are starting to get some very, very long lookup chains here because we're going like 4 levels deep. This will keep happening. Dealing with nested data structures is something that is unfortunately key to working with these because of how we lay out variables in most circumstances. Again, keeping it flat will help you. You don't have to do chains like this, but typically some level of nesting is inevitable because it makes it clear to reason about. So again, we've got these vars registered. We can see them being used here. We can then take this Jinja template we have here, and it's executed by Ansible with the vars we have, and it composites this. We'll go more into that when we have the lab section here. We're going to go briefly through what's possible with both the Arista EOS collection and the CDP collection. And then from there, I will give you your lab briefings for today, and we'll go into some questions we had outstanding around those labs. So, like we talked about, there is a lot of modules for internet devices in general. This is just a set of some of them for interacting with EOS. When Ansible built that EOS collection that they published for Arista devices, they fragmented out pretty heavily to the point where basically it's one module per feature. And for some features, it's multiple modules. Like you'll see, for example, there is an LDP module, there's an LDP global module, and there's an LDP interfaces module. It's a bit of a headache. It's part of why no one really uses these modules. What people end up using in most cases is using the EOS config module and the EOS API module. EOS API allows you to log into a switch over SSH and turn EAPI on if it wasn't already on, which is helpful. And then once it's on, you can speak to it and do config changes. There's also commands, of course, with the EOS command module to just run commands, get output, do various things. So you'll see typically people, including ourselves, when we drive direct change to AVD, we really use just those few modules and we ignore the feature stuff because it's just way too much. But beware, they are out there. Customers could use them, and then it's when we get to interesting things. The EAPI module itself.
Sorry,
Go ahead.
ask you a question. As new EOS releases are coming out, is there any process or any interaction between Ansible developers and Arista developers to make sure all those modules are still functioning properly?
No, and this is why we have problems. Because we don't own this and we don't own support for it, which is the exciting part because Ansible built this. So if a customer comes and says, hey, I created and it broke my module, we go, great. Open issue on GitHub. We have nothing to do with them. You'll see, of course, in the CP working group, we do things occasionally, like do basic testing for them for sanity checking, just to make sure it's not a playbook issue, it actually is a module issue. And then we'll say something like, yeah, it actually is just host for NTP, go open issue on NTP, or things like that. But there's no interlock. In our attempts to build one have not progressed quickly to this point. The difference between Arista.EOS as a module and the Arista.CP module and Arista AVD is that we own and control the Arista AVD module and the Arista.CP module. So we can make sure we have coverage there. We can make sure there's lockstep. We can't ensure that for the EOS module. And frankly, if we got control of it, we'd probably destroy 80% of these modules off the bat because they just don't make sense because they're way too spread out.
Yep, thanks.
So looking at module documentation, we'll go into this with a live view as well, the browser, but it's very, very important to understand how to read module documentation for Ansible modules because they always lay out what they expect, what they can do, and what the requirements are. This is an example of what the module documentation will look like for the eAPI module. You can see, of course, it's a little old because it says you need EOS 4 at 12 or higher, which is, I think, 7 years old at this point. But every module will have params like this. It will tell you what it needs, what it wants, what it can do. In this case here, something as simple as passing a var, an argument var, to the module when you're running on play with this Boolean will be enough to have it figure out and turn on or turn off the eAPI HTTP transport. And of course, you'll see here, this also tells you what collection it's part of. And the important thing is it'll tell you installation instructions and how to use it. So if you want to use this, you run this command and it downloads it to your system. Then to run it in a playbook, you do this. Let's take a look at some other documentation examples here as well. So we will pull these. This is obviously the documentation we're looking at before, but every module that is in Galaxy has a page like this, and you have all these params. Reading a page like this will show you what is possible with a given module. And typically, it will also have an example section like this, where it can show you how to use it. So in this case here, what this is doing is it's making sure that eAPI is turned on, but that you have the Unix socket on and you're turning off the HTTP protocol, you're turning on HTTPS. But then it also goes and it turns on the HTTP at port 80. So like this shows you as well, the examples don't always make sense, but they will show you the syntax to use, which is typically the more important part. And that gets back to where we can find some issues in these modules. But for any given module, a section like this will show you what happens. And then also crucially, you'll see return values here. And this will tell you what it can return back to you that you can register into vars to use for a later task if needed. So going through these, this is your SCP collection. This is a fun one. We built this and it allows us to automate a bunch of the abstraction away when it comes to working with Cloud Vision. Cloud Vision is a stateful system. So obviously, not every time we talk to it, we won't have to worry about creating every container in the system. We won't have to worry about creating every configlet. We only want to add the ones we need, delete the ones we don't, and map the ones we want. The Ansible CV collection makes it fairly simple for us. It pulls tasks from the system, it looks at what we're telling it to do in the configuration for the play, and it drives a delta. We use this in a lot of ways. We use this to drive the actual communication from AVD to CVP. We use this in pipelines to do changes for customers to do full CI/CD workflows, and we also use it in some cases for validation of a given system. For when customers want to use Cloud Vision, but have the provisioning stored in a Git-like system. Like this talks about here, just because you're using Ansible doesn't mean there's not a use for CVP. Even if you're managing your entire configuration state from Ansible, you will still be using CVP as your engine to speak to devices. It's doing things like storing your images and pushing them. It's doing the diff calculations with continuous compliance throughout your network. It's ingesting your telemetry data for your monitoring dashboards. It's handling your ZTP bootstrap. So just because you're using Ansible doesn't mean that CVP isn't a place. And we bring this up because sometimes customers ask and they go, well, why do I bother with Cloud Vision? I have Ansible. Cloud Vision is more than provisioning. It's more than just configlet provisioning. Ansible can't do all of it on its own, which is why we pair them. What you're going to find as well when we talk about the CloudVision module is that there is two versions. There's V1 and V3. We more or less skipped V2. V1 is legacy, but we were still using it in AVD up until the 4.0 release, which happens at the beginning of the month. It was old and kind of hard to work with. We now have everything covered to V3, and you can use V3 directly. And what we expose within this collection is these modules here to do various operations. I've got some basic descriptions here of these. If you want to know more, you can hit the link in the slides to view the full documentation. But effectively, we have modules to look at configlets, modules for containers, modules for devices. We can composite those together to create changes. And then eventually with those, you push out your tasks. And then obviously, if you want to, you can push a change control. Because these are modules that you're compositing within a play and a playbook, you don't have to use all of them. There is a section of customers who will go and create config changes from Ansible and create tasks, but they will not create change control. Once the engineers use Ansible, they'll go into the CloudVision system and review the task diff before they create and approve the change control manually. Other customers don't care. They will create the changes, create the task, and then create, approve, and run the change control all from within Ansible. And that's where this modularity comes in, helps them achieve what they want to do. Again, don't use V1. It wasn't great. It was also slow. Not much more to say there. This time last year, it was still needed for AVD. And actually, when we're using V3, we'll still need it. But as we move out to V4 and it gets more adoption, V1 is going away entirely. Again, installation, very, very simple. You can also install it from GitHub directly. This is usually done when you need to pull in a feature from the dev branch that is not yet available in mainline. Previous examples have been for things like ZTP support, strict mode bug fixes, things of that kind, but we really don't recommend that. And it usually causes problems for customers. One example that was, we had a large customer who was pinning a dev branch of this module to their pipeline and was asking why it kept breaking. Well, it's breaking because you're pulling development code into your production environment. And again, we'll talk some here about just how this playbook looks. You'll notice it starts getting longer than some ones we've seen so far for US devices. Part of that is because here we are using inline vars. One of the reasons for it to be inline is because we are using, again, Jinja substitution with Ansible directives to pull in text files and load the value as text files into these variables. So I've got this vars set up here where I've got a top level var called device configuration. Inside it has keys for my various devices. And then the value of those keys is loaded from those files. I also have a var for my containers, where I'm actually mapping out my tree of containers in the system. And you'll see here, of course, we're looking at what the parent is. We're using configlets if we attach them at the container level. And then we have this mapping below that, where we're mapping for every given device the container belongs to and the configlets to attach. And then once that's in place, we go and we actually fire off our task to build the topology and to configure devices. And because we've done all the work up front of building that var tree, we pass just that single top level object to the CloudVision module, and it goes and does all the work for us. This might seem like a lot of abstraction work to do up front for a one-time thing. What we have to realize is, as you go through and you add one device or two devices at a time to a network like this, you're just adding a line or two. And then the system calculates for you what needs to change, what has to be updated, and it drives that change. So how to debug. This is something that's going to be relevant as you start dealing with cases, and there's going to be more of those. There's a couple different ways that you'll end up looking at logging for this kind of thing. The first is like this says here, read the error messages. They usually have a good reason for why something has failed, and those will be emitted on a per task basis. That's a good place to start. We also have the ability to turn on a logging subsystem within Ansible and pull a log file they can give us to read. The other option, which we'll cover as well, is V flags. Ansible execution allows you to set multiple -v flags, and every V you add makes it output more and more low-level details. So 1-V gives you basic information statements. 4-V flags will start telling you things about how you're doing a stage connection, for example, and things like that. Beyond that, you can also look at the actual docs in the CLI for a given module if you're trying to troubleshoot what they're doing with that. And of course, like we showed earlier, there's the online docs as well, either on the GitHub project or on the Ansible collection page. All right, so lab time. Actually, before we get to that, any questions on what I've covered so far in the collection part there? All right, cool. So labs it is. Again, rehash. We have answers in a separate branch here. Before you do the labs today, you should pull down the repository from GitHub again. I did update it last night and this morning to account for the dual lab topology and validate that will work there. You're going to have a number of files to work with because we have 24 devices. Lab 1 is fairly simple. You're going to run through building out inventory and group var files and verifying you've done it correctly so you can ping all the devices. Once you've done that, you're going to verify you understand how to ping just the spines and just the leafs. You also pull some basic commands, in this case, show version and show IP interface brief, and store them in files. So a few modules, some group var work, get your feet wet. From there, we're going to talk about how you can directly operate on devices. Here you'll be using the Arista EOS collection we've been mentioning, and you will configure device banners, you will turn eAPI on, and you'll set your login severity. That'll give you a chance to use a few modules from that collection and do some basic logic. Once that's in place, you step up a little bit and we go and do a full Arista CUP deployment with the CUP collection. This will use outputs you build in Lab 2 to create configlets that you apply within the system. Again, detailed instructions are in the lab notes, and we'll go from there. And then Namdi, I think you had a question about Lab 3 from yesterday, correct?